try to understand what infinity is. We're going to write our functions. In this case it's 1 over x. And we're going to try to find the limit in the left and in the right of 0. Okay, we're going to see what happens when I'm approaching to 0 in x. Where my function is approaching, or the value of y. Well, I can say, for example, this point, when I am approaching in x to minus 2, the value of y is approaching to minus 0.5. But what happens when I am approaching to 0 is going to decrease, and is going to decrease quickly. Look, minus 1.5, minus 1, minus 1. 0.5 now is negative 2. And as you can see here, if we go more closer to 0, minus 0.4 and minus 0.2, I'm getting values very low. Okay, look here, I am closer to minus 4.8 and continue. What happens if I get closer? Minus 0.1, do you see? Have a value, very big value. What is telling to me? It doesn't matter how close I get to the 0. I'm going to get a lower value here in y. And that's going to be my infinity point. If I can see this graph, it doesn't have a limit. It doesn't matter how close I am to 0. I always have a graph there, and it's going to be very close to 0, but it's never going to touch it. But what I know is I am going to minus infinity, because I am getting closer to a big number when I am getting closer to 0. Now, what happens when I'm getting closer to 0 in the other side of the y-axis? Well, as you can see here, when x equals to 2, y is equals to 0.5. But now, when x equals to 1, y equals to 1. And when x equals to 0.5, y equals to 2. But if I'm getting closer again, I'm going to do exactly the same thing in the right side of the 0. And as you can see, it happening the same thing. But now I'm going up. I'm getting a bigger and a bigger number in the positive side of y. Then it doesn't matter how close I get to 0, I'm always going to get a big number. That's why I can say I can go to positive infinity. Well, now I know if I need to say the limit exists, it needs to exist, it needs to be the same number. This needs to be equals to L, and this needs to be equals to L. But what happening here? When I'm getting closer to 0, in the left of 0, I'm getting closer to a big number, and then I'm just going to say it's minus infinity. And when I'm getting closer to 0 in the right, I'm getting closer to a big number. But in this case, the big number is going to be positive in y. Because the limit when x approaches to 0 of f of x is not the same as the limit when x approaches to 0 in the right. Then the limit, it doesn't exist. Now we can see it numerically. For example, when x is approaching to 0 to the left, that means all the values less than 0. If x is minus 0.1, then f of x is 10. Minus 0.01, minus 100. Minus 0.001, x equals to y, the value of y is minus 1000, and go on until it's minus 0.000. Remember, you can write as much as 0 as you want, but we can stop here. Now we have minus 10,000, and in the other side is going to be the same: 10, 100, 1000, and 10,000. But this is negative numbers and this is positive number. Then because minus 10,000. Be careful here, because when I want to say the limit of f of x, the limit when x approaches to 0 of f of x, when I'm doing to the left, I stop at minus 10,000, but the answer is not minus 10,000. It's just a big number, remember. And how I'm going to write that word? Well, instead of to write that, I'm just going to write minus infinity. And it's going to happen in the other side. I can't write 10,000 because it's not the last number that I can find. If I add extra zeros here, I'm going to have an extra zeros in this side. That means it's going to be a big number. Then the limit when x approaches to 0 to right of f of x is equals to positive infinity. Then the limit, it doesn't exist. You can do it algebraically or you can find it graphically. Sometimes we need to determine limits when the input gets larger and larger with out of bound. That is, the input approach to infinity. In such cases, we are finding limits at infinity. Such as limit is expressed as the limit when x approaches to infinity of f of x, or the limit when f of x approaches to minus infinity. These limits are approached from one side only. That's very important because we are not going to compare both. From the left, if approaching positive infinity, or from the right, if approaching negative infinity. Using the same example, if I want to determine, let f of x is 1 over x. If I want to determine the limit of f of x when x approaches to infinity, well, where is going to be the value of f of x, the value of y, if x approaches to infinity? As you can see, the value is decreasing here in y. And if I am getting longer in x, the value of y is going to be smaller. That means I can say this limit is going to be 0. Now, when x approaches to negative infinity, what is going to be the value of f of x? What is going to be the value of y? If I start with minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, I can see when I'm approaching to the negative infinity, the value of y is approaching to 0. Then the limit is going to be equals to 0. Now let's try to understand what happened with the graph 1 over x minus 2 plus 3. As you can see, this is the same graph as 1 over x, just I move my axis of symmetry 2 units to the right and 3 units up. It's important to understand where are going to be my asymptotes. I'm going to have my vertical asymptote in x equals to positive 2 and my horizontal asymptote in x equals to positive 3. Now, let's try to find the limit when x approaches to positive infinity of f of x. Where is the value of y? Where is my function approaching when I am approaching to infinity? Well, to positive infinity, remember we have all these numbers. But what is happening with the value of y? Where is it? The value of y is approaching to the number 3. Then, graphically, I can say when the value of x is approaching to the positive infinite, the value of y is approaching to 3. And algebraically, I can represent it like this. I can try values. What happens when x is 5, f of x is 3.3, when x is 10, 3.125, when x is 100, 3.01, when x is 1000, 3.00, and I can continue. And the values of f of x, the value of y, are going to be more closer to 3, Then I can say for sure, when x is approaching to positive infinite, f of x is approaching to 3.